Hey everyone, we're solving this physics paper today. Is Physics, May June 2021, 9702, paper 1-2. The threshold is like this: A is at 28, B is at 24, C is at 20, D is at 16, and E is at 12. Alright, so let's begin with 1. What is not a reasonable estimate of the physical property indicated? 2 into 10 power 2 watts, 2000 watts for power dissipated by heating element. That looks fine. Basically, your goal here is to find out something that's really odd. Okay, find out the odd one out. 400 meter cube, 2000 watts. 400 meter cube for the volume of water in a swimming pool, and 50,000, right? 50,000 newton seconds. That's fine for a vehicle like a lorry. What about this? The weight of a fully grown racehorse, 600 newtons. Does that make sense? That's our weight. Our weight is around 600 newtons. That's the average weight of a human being, right? If you have a mass of around 60 kg, you're gonna have a weight of 588 newtons. So this is clearly wrong, okay? The horse clearly weighs more. Which quantity could have the units of Newton meter per volt? Okay, so to figure this out, let's do it step by step. So volts, right? Volt is basically work done by charge. Understood? Volt is basically work done by charge. So this is actually Newton meter by volt, right? So volt is basically, work done is basically joules, and charge is basically Q is equal to IT ampere seconds. So volts is basically, about joules. Joules is actually work force into distance. So Newton meter divided by ampere second. So this can be written as Newton meter divided by Newton meter divided by ampere second. So we can actually get rid of this, and after reciprocal you end up with ampere second only. So ampere second, that's the unit of charge. Q is equal to IT ampere second. Okay, 2B. Now let's move on to 3. An object is acted upon by two forces, 10 Newton in the vertical direction and 6 Newton at 40 degrees to the vertical as shown. So let's try to figure this out, right? Come on. I had it done already. Let me do it for you again. So if you look at the figure, right? The 6 Newton force has two components. One is 6 cos 40, the other is 6 sin 40. So the resultant force in the x direction is just 6 sin 40. So that's 3.8567. That's it. In the positive direction to the right. Okay. What about the resultant y? It's actually 10 minus 6 cos 40, right? 10 minus 6 cos 40. That gives us a value of 5.4037. Okay, 5.4037. So let's find out the resultant force now. So the resultant force should be Rx square plus Ry square, resultant square. So answer square plus 3.8567 whole square, and root over answer gives us a value of R is equal to 6.64. So wait, that's our answer, right? That's it. We have our answer. It should be D, 3D. No other answer matches. I can also show you the direction, right? So basically the resultant y is also positive, x is also positive. So it's like this. Resultant x is like how much? 3.8. Wait up. And resultant y is like 5.4, right? So if you want to find out the angle, the angle is with the vertical, right? This is theta. So if this is the triangle, okay, and this is theta, you know that this value is 3.8 and you know that this value is 5.4. So tan theta is equal to 3.8 by 5.4. Tan inverse. That gives us a value of 35 degrees. 35.13 degrees. So the closest answer is 36. I didn't use the exact values, right? So if we use the exact values, 3.8567 by 5.4037. Let's do this. 3.8 567 by 5.4037. Tan inverse answer gives us a value of 35.5. Yeah, 35.5 or 36 basically. Yeah. Moving on to 4, this is an analog ammeter with a range of 0 to 250 milliamperes. It is connected into an electrical circuit. The diagram shows the ammeter's display. What is the reading of the ammeter? Okay. So this is 6, this is 7, this is 8. Now hear me out. So it has 5 divisions in between. So this is actually 7.2, 7.4, 7.6, 7.8, then 8. So that's actually at 7.246, 7.6. The reading, the analog reading is at 7.6. If you zoom in, you can see it properly. Okay, it's at 7.6. The third division, right? 2, 4, 6, 8, then 10, which is 8. So guys, look at the whole reading. It reads from 0 to 250. 0 to 10 corresponds to 0 to 250. So we know that a reading of 10 will correspond to 250 milliamperes. So what about a reading of 7.6? What does it correspond to? 250 by 10 into 7.6. 250 by 10 into 7.6 gives us a value of 190. 190 milliamps, so 4 is D. Moving on to 5. Students take readings of the volume of liquid using 3 different pieces of measuring tape, measuring equipment, X, Y, and Z. The true values of the volume of the liquid is V. The student results are shown. How many pieces of equipment are precise and how many are accurate? So accuracy actually means how close your calculated value is to the true value. Like hear me out. Here the true value V corresponds with the peak, right? The most common value. Similarly, for Z that also works. It corresponds with the peak. But for Y, the calculated value is around here, but the true value is here. So we probably had a systematic error, right? So clearly X and Z are accurate but not precise. So 2 of them are actually accurate. Now let's go to the next one. What about precision? Precision actually refers to the range of values. Look at this. X is so spread out, but look at Y. Y is precise because the range of values is much smaller. When it's concentrated in a very small region, or if the peak is very sharp, that means your equipment used, they were very precise. Do you understand? That's why both Y and Z are actually precise, and X and Y, X and Z I mean, were accurate. Moving on to 6. Which graph shows the variation with time t of the velocity v of an object falling vertically downwards in a vacuum. Okay, so since you're falling down in a vacuum, you will always have the acceleration of free fall. So acceleration will be constant and velocity will be increasing at a constant rate. So the correct answer is actually D. Moving on to 7, a projectile is fired from point P with velocity v at an angle theta to the horizontal. It lands at point Q, a horizontal distance r from P. Air distance is negligible. Which equation about r is correct? So basically guys, r is called the range of your particle. The range totally depends on the horizontal velocity. Understood? It's constant. The horizontal component of velocity is always constant. You need to remember that, okay? So how are we going to do this actually? The horizontal component of velocity is v cos theta and the vertical component is v sin theta. Typically it should have been v cos theta into time t, but as you can see from the options given, there isn't an option like that. They somehow integrated v sin theta inside here, okay? Let's see how. Let's try to figure this out, right? So which equation for r is correct? We can use the equations of motion, okay? Starting with this, check this out. We know that v is equal to u plus at, right? What is our final velocity when the projectile is going to hit the ground? Since we're taking the initial velocity to be positive, that means the upward velocity of plus v sin theta. At the end of the journey, the vertical velocity will be minus v sin theta. So if I incorporate that into this equation, minus v sin theta is equal to v sin theta minus gt. Gt is equal to 2v sin theta, and time is equal to 2v sin theta divided by g. So what is this? This is the time taken for the particle to, travel this whole horizontal distance. Okay. Or you could do something, you could find out the time taken to reach the maximum point using v is equal to u plus at. 0 is equal to v sine theta minus gt. So time is equal to v sine theta divided by g. Then you could just multiply it by 2, okay? Because you're going to take the same time to travel this distance, right? Okay, moving on. What did I do in the next part? I just told you that the formula for range is we have to use s is equal to vt because velocity is constant. So range is equal to v cos theta into time, and we know the time, right? We know that r is equal to v cos theta into time 2v sine theta by g. So what's the final value of r? V 2v square, right? Followed by sine theta cos theta divided by g. We're going to be looking for that, and our answer is B. Okay, our answer is B. Hopefully you guys get it. So for number 8, a box of weight W is at rest on a table. Sorry. A student attempts to state Newton's third law of motion by saying that action equals reaction. Okay, this is a trick question. Basically, you need to understand that according to Newton's third law, pair forces must be of the same type. The weight of the book is the action force. What is the reaction force? So the weight of the book, why is this actually occurring? The weight is a gravitational force. The earth is actually pulling the book. So its pair force must be, right? Since the earth is pulling the book, the book must also be pulling the earth. And it must act in opposite directions. So it can't be downwards. It will be upwards. And the force, since this W is acting downwards on the book from the earth, so the reaction force must be acting upwards on the earth from the book. Okay, so there's nothing to do with the table here. You guys need to understand that. 8 should be C. There's nothing to do with the table or the floor. That's for the reaction force, which is a contact force, not a gravitational force. 4 balls are dropped at the same time from the top of a very tall tower. There is no wind resistance, wind blowing. Which ball hits the ground first? Okay, so they're dropped at the same time. Which ball hits the ground first? Think about it. Density is equal to mass by volume. So these are all spherical. So density is equal to mass divided by pi d square by 4. So which ball will hit the ground first since there's no wind blowing? Basically, it will be the most dense ball. Okay, it will be the most dense ball. If it was a vacuum, they'd hit at the same time, but since it's not, density will actually determine the time at which they drop. So clearly we are going to look for highest mass and least volume or least diameter. So the answer is B. It has the greatest mass and the diameter is less. Okay. For 10, nitrogen molecule P traveling at speed 320 in a vacuum collides with the stationary nitrogen molecule Q. After the collision, P travels at velocity 180. Q travels in a direction at an angle 34 degrees to the initial path of P. Assume that there are no external forces acting. What is the magnitude of Q after collision? Okay. So basically, we only had horizontal momentum before collision. So after collision, we must only also have horizontal momentum. So we can say that since both of them are nitrogen molecules, actually, their mass is the same. So equating horizontal momentum, 320 into m plus 0 is equal to, horizontally, 180 m cos 55 plus v m cos 34. V cos 34 into m. 180 cos 55 into m plus v cos 34 into m. That's one equation, and we can get rid of the m's. And the other equation goes like this. Basically, there was no vertical momentum before the collision. So after collision, there must also be no vertical momentum. Okay, horizontal or vertical momentum. There was no vertical momentum before collision, so there must also be no vertical momentum after collision. So we can actually equate those. They are in opposite directions, so they'll be cancelled out, right? So we can say that 180 sine 55 into m, 180 sine 55 into m is equal to v sine 34 into m. So you can use any formula you want, actually. It's up to you. We can use this. This is much simpler. So let's do this. 180 into sine 55 divided by sine 34 gives us a value of 263. So the nearest answer is 260, 260, right? Meters per second. So that's it. 10 is D. Moving on to the second section. 11. The charged particle. We don't have this. Fields are no longer in our syllabus. That's why we don't have to do 11. Okay, moving on to 12. Torque of the couple. Torque is basically net moment. It's the distance between the two forces and the product between the distance between product of the distance between the two forces and any one of the forces. Okay, so the total distance is 2r. It's going to be 2rf. So 2rf, 2fr, 12 is c. Moving on to 13. This is a tricky one. Okay, 13 is actually tricky. Let's do this carefully. I'm going to show you how I did it. So a uniform square sine, okay, of sides 0.8 meters is suspended vertically from its top edge by a horizontal hinge as shown. We are given a front view and a side view. The hinge is not frictionless. When the sine is displaced from the vertical by an external force and then released, it does not return to its vertical position. Okay, it stays there. When it's displaced by an external force and then released, it does not return to its original position that we're seeing on the diagram. The maximum torque exerted by the hinge on the sine is 6 Newton meter. Okay, that's the friction basically. The frictional force is basically counteracting the moment provided by the weight. The frictional force is counteracting the moment provided by the weight, and the moments are cancelling out, and at the end, the object remains at equilibrium. The sine is displaced by 90 degrees so that it is horizontal, okay, and then gradually released. So I'm going to explain the whole scenario. Initially, the sine is vertical, then it is displaced by 90 degrees so that it becomes horizontal, as you can see from my diagram on the right. Okay, so let's do this step by step, slow and steady. All right, this is the initial case, right? It was vertical, we rotated 90 degrees, okay, so that it is horizontal. Now this was vertical, now this is horizontal. Okay, now hear me out. What's going to happen when it's kept horizontal? It's obviously not going to stay there. When we let it go, it's going to try to come back to the original position, but remember, it does not return to the vertical position. Okay, so how is the moment going to act, and what is providing the moment? The moment is provided by the weight of the sine. Since it's uniform, the weight will be acting at the center of mass or the center of gravity, which is the geometrical center, right over here, 0.4 meters from each side, 0.4 meters from each side, and weight acts vertically downwards. Okay, so this is the moment, this is the weight. The weight is 40 newtons, right? It's given in the question, and it's going to act through the geometric center. It's going to act through the geometric center of the object. Okay, so if you think of the pivot will be at the hinge. So the distance, the perpendicular distance from the pivot is 0.4 meters, and the weight of the sine is 40 newtons. So what's the moment actually? It's gonna be 40 into 0.4, 60 Newton meters. Okay, so that's the moment provided by the weight when the sine is horizontal. Now, hear me out. So we're gonna get, according to my diagram, we're gonna get clockwise moment. However, the maximum torque exerted by the hinge on the sine is 6 Newton meters. At one point, okay, the friction will provide anti-clockwise moment, which actually prevents the sine from returning to its original position. So it's gonna stop midway between these two instances that I've drawn. Not vertical, not horizontal, something in between. It's gonna be something like this, okay? It's gonna stop somewhere here. It is neither vertical nor horizontal, somewhere in the middle basically, okay? So let's see how I actually figured this out, where it stops, okay? So basically, since the weight is providing a clockwise moment, the friction will provide an anti-clockwise moment, okay? So let's look at the figure step by step. I'm gonna draw another one, don't worry. So this was our hinge. The weight acts to the geometric center. I'm drawing the geometric center now. This is 0.8, right? So the center is at 0.4. Okay. And this is our hinge. This is the hinge. Okay, so our weight is trying to provide a clockwise moment, but it's being counteracted by the friction provided by the hinge of 6 Newton meters over here. Now, you remember guys, moment is only provided by a force that has a component perpendicular to the distance from the pivot, okay? So, think of this angle. Our goal is to find out the angle to the vertical. At which angle to the vertical does the sign hang after release? So our goal here is to find out this angle, the angle to the vertical. Because if I draw a straight line through this, look, weight always acts vertically. Remember that. That never changes. This is the vertical, okay? This is the vertical, and we're tasked to find out this angle, the angle between the vertical, right? The angle to the horizontal, to the vertical, at which the sign actually hangs. But listen, we cannot take the component. We cannot take the component that's like, you know, parallel to the blue line. Why? Because then the force would be passing through the pivot. Get it? And that can provide no moment. So which force am I gonna take? I am going to take this force actually, this component. So what component is this? This is the component that's perpendicular, right, to the distance from the pivot of 0.40 meters. And this makes sense, right? So now we know that the anticlockwise moment will be equal to the clockwise moment at this instance where the sign stops. The anticlockwise moment is fixed at 6 Newton meters. This is totally fixed, okay? Now, the clockwise moment will be, this component is actually W sine theta, right? So W sine theta into the distance 0.4 is equal to 6 Newton meters, okay? So 6 divided by 0.4 divided by the weight, which is 40 newtons. So we're getting a value of sine theta is equal to 3 by 8. Then sine inverse answer gives us a value of 22 degrees. Theta is equal to 20 degrees. So that is it. That's why answer is B. Quite a complicated sum. That's why it took some time to explain it. Be careful about this, okay? 14. So each foot of an elephant has a circular cross section with circumference 1.4. The elephant has a mass of 5,400. The element is standing still with all 4 feet on the ground. Assume that the pressure under each foot is the same. What is the approximate pressure exerted on the ground by each of the elephant's feet? So there are 4 feet, right? So we have the circumference. 2 pi r is equal to 1.4. But to find out pressure, we need area, right? We basically need pi r square. So let's find out r. R is actually 1 by 4 by 2 pi. That's our radius. Now, Let's think about the total pressure first. What's the total pressure? Okay, so yeah, pressure is force by area. So since they want the pressure exerted on the ground by each of the elephant's feet, okay, we need to think of it in a different way. So the elephant, right? It has 4 feet. I'm just drawing a box here. Now the total weight is 5,400 kg, the mass, right? It will be divided into 4 parts, okay? Since we want to find out the pressure exerted by each feet, we want to know how much load is each foot taking. So each foot is taking a force of 5,400 into 9.81 divided by 4. This is the force or load taken by each foot. Now the area of each foot, what's it gonna be? Pi r square, right? So P is equal to 5,400 into 9.81 by 4 divided by pi into 1.4 divided by 2 pi whole square. Let's do this. 1.4 by 2 pi whole square into pi, and in the numerator we have 5,400 into 9.1 into 0.25 divided by answer. It gives us a value of P is equal to 84909 pascals, or 8,000 divided by 1,000 is 84.9 or 85 kilopascals. So our answer is C. Okay, hopefully you guys get it. Moving on to 15. A stone is falling vertically through the air at terminal velocity. Which energy change is occurring? Basically, since energy is constant, the velocity is constant, kinetic energy is not changing. Do you guys understand? So what's happening? You're losing height. So GP is being converted, but it isn't changing to KE. It's being lost as heat, right? So wherever you see KE, that's wrong. The answer should be A. 16. An object of weight 12 Newton rests on a platform on top of a container with 2 pistons is shown. The container contains a fixed mass of gas and the pistons are free to move. The plunger is slowly pushed 4 centimeters to the left. This one is moved 4 centimeters to the the plunger is slowly pushed 4 centimeters to the right. Okay. As a result, the object slowly moves upwards a distance of 0.5 centimeters. How much work is done on the object? So listen, work done is force into distance moved. Now, the force that we had to work against was 12 newtons. So, we did a work of, like, we moved it a distance of 0.5 centimeters. So, logically, it has nothing to do with this. We will only be looking here. So, work done is equal to the force that we worked against, and we moved it to a distance of 0.5 into 10 power minus 2 meters. 12 into 0.5 into 10 power minus 2 gives us a value of 0.060 joules. 16 should be A, logically. 17. A constant force F acting on a car of mass m moves the car up a slope through a distance s at constant velocity v. The angle of the slope to the horizontal is alpha. The acceleration of free fall is g. What is the ratio of gp gained by the car divided by work done by force F? Okay, so the work done by force F is pretty simple, F into s. Okay, what about the gp gained? Let's try to understand. Basically, there was some work done against gravity. Do you guys understand? There was some work done against gravity. Now, the weight acts vertically downwards, and this angle is alpha. So we actually worked against this component of weight, this one over here. That is mg sine alpha. We worked against the sine component of weight. Not the whole thing, just a portion of it, the sine component basically. And we successfully moved through a distance of s. So we know that work done is equal to force into distance. Now, the force that we were working against was mg sine alpha, and the distance moved was s. So that's the gp gained by the car, mg sine alpha into s. Now, the work done by the driving force was fs, and we can get rid of this s. We're ending up with mg sine alpha by f. The answer is D. Okay, 17 D. Moving on to 18. What is the definition of power? Remember that power is the work done by time. rate of change of work done, basically. Sorry, rate of change of, yeah, work done. So 18 is the best answer. Now a steel bar of circular cross section is under tension T as shown. The diameter of the wide portion is double the diameter of the narrow portion. Okay, so this is actually 2D and this is just D. What is the value of stress in wide portion by narrow portion? So stress is basically force by area. Okay, so we are applying the same tension T. So tension T is applied, but in the wide portion it's pi into 2D by 2 whole square, and in the narrow portion it's T divided by pi into D by 2 whole square. Okay, so we can get rid of the T's, we can get rid of pi's, we can get rid of these 2's. So 1 divided by D square divided by 1 divided by D square by 4. So after reciprocal, you're going to end up with this. Basically, here we end up with 1 by d square divided by 4 by d square, right? And you can get rid of d square. Okay, so you're ultimately getting a value of 1 by 4. So the stress in the narrow portion is 4 times that of the stress in the wider portion, although the force is the same. So 1 by 4 translates to a ratio of 0.25, and 19 should be A. Hopefully you guys get it. 20. Two guitar strings are stretched by tensile forces. String X is stretched by a tensile force F that causes an extension X. So for string X, it's half Fx. For Y, it is stretched by tensile force 2F and causes an extension of twice X. So the strain energy is going to be half into twice F into twice X. Okay, so we can get rid of these. We can get rid of this and this. We end up with 1 by 4. So 20 is D. Straightforward. Two lasers emit light in a vacuum. One laser emits red and the other emits green. Which property of the two lasers must be different? So remember that both of them are visible light, so speed must be the same. Okay, but since wavelength is different, frequency must also be different. Okay, trick question. But there is no guarantee that amplitude or intensity are different. Okay. 22. Two particles in a progressive wave are a distance 10 centimeters apart. The two graphs show the variation with time d of the displacement of the two particles, displacement d. What could be represented by the two graphs? Particles in a longitudinal wave with a compression and the nearest rarefaction separated by 10 centimeters. Wait, two particles in a progressive wave are 10 centimeters apart. So for a longitudinal wave, you guys know that the particles vibrate parallel to the direction of energy propagation, right? But here we are seeing that the vibration is up and down. Okay, the vibration is up and down. It seems like that. Okay, so let's see how we can figure this out. Two particles in a progressive wave are a distance 10 centimeters apart. The two graphs show the variation with time, t of the displacement, d of the two particles. Okay, particles, what could be represented by the two graphs? Particles in a longitudinal wave with a compression and the nearest rarefaction separated by 10 centimeters. Look at this. This is an interesting fact. Look at these two particles. One is starting from the highest point while the other is starting from the least point. Do you know what that means? This means that there is a phase difference of 180 degrees between the two waves. Since one is starting from the highest displacement and one is starting from the least. This means that these two particles, okay, that are separated, I'm just drawing a random figure. These two particles that are separated, one is starting from the top, the other is starting from the bottom. This means that the distance between them actually represents the distance between a crest and a trough for the case of a progressive wave, or the compression and rarefaction in the case of a longitudinal wave, It's compression and rarefaction, and crest and trough for a transverse wave. But that's 10 centimeters for sure. So remember, it's either compression to rarefaction or crest to trough. Crest to trough. We're going to look for that. Particles in a longitudinal wave with a compression and nearest rarefaction separated by 10 centimeters. That looks like the answer. So A is it. But B, compression and nearest rarefaction separated by 20. That's wrong. Particles in a transverse wave with a peak and nearest trough separated by 10. If this was 10, it could have been the answer. Particles in a transverse wave with two adjacent peaks separated by no. Peaks refer to crests. So they're saying that 10 is the wavelength, but no. The wavelength is actually 10 into 2, 20. Okay, the wavelength is 20. Moving on to 23. A sound wave is detected by a microphone that is connected to our CRO. The screen of the CRO displays a waveform as shown. The time base is set to 20 microseconds per division. What is the frequency of the wave? Okay, let's try to figure this out. We're going to take 2 points. Sometimes they won't pass through, you know, the exact point, right? So why don't we take this point? So that's 1 box, 2 boxes, 3 boxes, not 4, less than 4, not 3.5, less than 3.5. It's kind of like 3.25 or 3.3, right? It's kind of like 3.25 or 3.3. I'm going to go with 3.3. So it's 3.3 divisions. So what's the time period? 20 into 3.3. That's actually 66 microseconds, or 66 into 10 to the power minus 6 seconds. Understood? Now frequency is equal to 1 by time period. So 66 into 10 to the power minus 6, 1 divided by answer gives us a value of 15151 hertz, or rounded off to 15,000 hertz. That's the best answer. 23 is B. Okay, all good. 24. A person stands at the side of a straight railway track. A train moves towards the person and emits sound from its whistle. The person hears a sound of frequency 1690 as the train approaches him. The person then hears a sound of 1500 as the train moves away from him. The speed of sound in air is 340. What is the speed of the train? Okay. So when an object approaches an observer, frequency increases. When it goes away from him at constant speed, frequency decreases. So when it was going towards the observer, it was like this. The observed frequency is equal to frequency of source into velocity of the wave divided by velocity, since we want to make it bigger, minus velocity of source. So the observed frequency was 1690 as it approaches him, is equal to fs into 340 okay, divided by 340 minus Vs. That's one equation. What about the other one? 1500 when it was receding is equal to frequency of the source multiplied by 340 divided by 340 plus Vs. Okay, so let's do this. We can do it. 1690 into 340 minus 1690 Vs is equal to 340 Fs. On the other hand, 1500 into 340 plus 1500 Vs is equal to 340 Fs. So our goal here is to find out the speed of the train, or the velocity of the source, right? So let's do that. 1690 into 340. 574600 minus 1690 Vs is equal to 340 Fs. And here 1500 into 340, that's 510000 plus 1500 Vs is equal to 340 Fs. We want to get rid of Fs, right? So let's make Fs the subject here. Fs is equal to 574600 minus 1690 Vs divided by 340. So 510000 plus 1500 Vs is equal to 340 into 57600. Oh, I could have substituted this better. Sorry, my bad. Well, I am already seeing that 340 Fs is the common thing over here, right? So we can just substitute that. Okay, so we can actually write, This one was 5100. Wait, we have this over here, right? So we can just go with this. Let's substitute this. 574600 minus 1690 Vs is equal to 510000 plus 1500 Vs. Okay, so 1500 plus 1690, that's 3190 Vs. 574600 minus 510000. This is so annoying. 64600 divided by 3190, that gives us a value of Vs equals to 20.3. Okay, let's look for answer. 24 should be A logically. Yeah. 25. Which list shows us the order in electromagnetic waves in order of decreasing frequency? Gx, UV, IMR. That's the mnemonic. Gx, UV, IMR. This is increasing lambda or decreasing frequency. So gamma, it should be gamma first, followed by ultraviolet, not infra. So 25 is B. 26. A pipe of length L is open at one end and closed at the other. Now, a loudspeaker is at the open end and emits a sound wave into the pipe. When a station wave is formed, there is an antinode at the open end of the pipe. Which wavelength could be used to produce a stationary wave? Okay, so this is the first pattern. When one end is open and the other is closed, these are the patterns you'll be looking at. Okay, these are the patterns. One of them is this, the other is this. Okay, so antinode here for sure. So this is antinode to node. So that's lambda by 4. So lambda by 4 is equal to L. Lambda is equal to 4 times L. Do we see that? No, that's not an option. Let's move on to the next pattern. So the next pattern is like this. This is the next pattern. Okay, so this is antinode, antinode, node. Antinode to antinode is lambda by 2. Antinode to node is lambda by 4. So 1 by 2 plus 1 by 4, that's 3 lambda by 4 is equal to L. Lambda is equal to 4L by 3. Are we seeing that? Yes, we are. So 26 is C. 27. Which diagram best shows how water diffracts when they pass through a gap in a barrier? Okay, so the wavelength is much greater than the width of the slit, so there should be good diffraction. So the main thing is after diffraction occurs, wavelength remains the same. Okay, so D and A are clearly wrong. It's between C and B. So the thing wrong with C is that look at the wavelength before diffraction. It is much less than the wavelength after diffraction. That's why C is wrong. But look at B. Wavelength remains the same. That's why 27B is the answer. Okay. 28. In a two-source interference experiment, light of a single frequency is incident on a double slit. The light waves emerging from the slits are coherent. What is meant by coherent? You need to memorize this. Two waves having constant phase difference. Okay. 228 is B. Moving on. 29. A parallel beam of light consists of light of wavelength 420 and light of wavelength 630. The light is incident normally on a diffraction grating. The diffraction maxima for two wavelengths overlap only at an angle of 31 degrees from the direction of the incident light beam. What could be the line spacing of the diffraction grating? Interesting question actually. Let's see if we understand, okay? Come on. I did a lot of working for this. Come on. Okay, so here's the basic thing. Light at 420, it's kind of like blue. This is blue light. And light at 630, it's like orange. Okay, let's just consider it to be red. Okay, just for the sake of it, making things easier. So that's blue and that's red. So you need to understand that the greater the wavelength, the more you diffract. The greater the wavelength, the greater the diffraction. So it can be like, when can they overlap? It can be like this. Basically, the third order of blue light and the second order of red light, because red diffracts more, right? it can never be like this. Hear me out. It can never be like the second order of blue light and the second order of red light. This is not possible because red obviously diffracts more, and it also can't be like this. Like it can never be the second order of blue light and the third order of red light, because here's like it's like this. If this is a screen, red diffracts more. Get it? Like the zeroth order will be the same for both of them, and it's kind of like this. If I draw blue light over here, this is the first order of blue light, second order of blue light, third order of blue light, for example. Now if I draw red, it's gonna be like this. For example, the zero order will match. So the first order may be here, the first order may be here, okay? Now the second order may be here, it diffracts more. Now the third order, okay, will obviously be here. So when can they actually correspond? In which scenario will they correspond to each other? Okay, I'm going to teach you. For example, let's draw this diagram again. First order of blue light, second order of blue light, third order of blue light, for example. Now, here's the thing. This may happen. For example, for red light, the first order may be here, and the second order may actually correspond with the third order. They may be at the same angle. You never know. Okay, so it's always going to be like this. The wavelength, okay, the wavelength that is shorter will always have the higher order. Like it may be like this. This can be 3, this can be 2. It can also be 4, 2. That's too much though. It's either 3, 2 or 2, 1. It's going to be something like this. That's for sure. Okay, now come on, let's see the working. So we know that d sin theta equals to n lambda. We want to find out the value of d actually, right? We want to find out the value of the spacing d. And we know that the angle is 31 degree. Okay. So let's start. So we are gonna try trial and error. Like I just told you, what are the possibilities? It will either be, 3, 2 or 2, 1 even. That also works. These are the possibilities. 3, 2 or 2, 1. Let's see. You guys need to understand something though. Like let's make this sum a bit simpler for you guys. The value of theta is constant at sin 31. Okay. And the value of d is also constant. This thing over here, this is actually a constant. So d sin theta is a constant. What is changing actually? N and lambda are changing. Okay, they are going to change. N and lambda. So we can say that n lambda is equal to constant. So for red light, what is it? 630 n is equal to constant. And for blue light, it's 420 n is equal to constant. So let's try the possible combinations that I just gave you. Okay, like 2, 1 and 3, 2, or even 4, 3. Let's just keep on going until it matches. All right. So let's try 2, 1 first. 2 into, and the higher number will go to blue light, the one with shorter wavelength. So 2, 1. So 2 into 420 is 840, and 1 into 630 is 630. That did not match, so this is a no-go. This is wrong. Okay. Next. Why don't we try 3, 2 now, or 3, 1 even? Okay. So I'm trying 3, 2. 3 into 420 is equal to 1260, and 2 into 630 is equal to 1260. So we have our winner. It's going to be 3, 2, the third order of blue light and the second order of red light. Okay, so now we just have to input it with any one of these. Let's input it in the one for blue light. So it's actually d into sine 31 is equal to 3 into 420 into 10 to the power minus 9. Now I have to take the minus 9 into consideration because I'm actually doing math. 3 into 420 into 10 to the power minus 9 divided by sine 31. That gives me a value of d is equal to 2.45 into 10 to the power minus 6 into 10 to the power what's the unit actually? Millimeters? Yeah, micrometers into 10 to the power 6 gives us a value of 2.45 micrometers. Let's look for that 2.45. Okay. Yeah, our closest answer is actually C, 29C. Tricky sum, right? 30. A positive charged particle is in an electric field. We don't have this in our syllabus. Skip. Go to 31. This is not in our syllabus either. Moving on to 32. A wedge shaped metal conductor of length L with varying width and uniform thickness is connected to a cell as shown. Which one shows the how the drift velocity changes with distance x from end x to y? We're going from left to right. So we know that I is equal to, guys, I is equal to NAVQ. So we want to find out V. V is equal to I divided by NAQ. The logic is this is a series circuit, so current is constant. Okay. Now N is also constant, Q is also constant. This depends on the material, and Q is always constant, always. Now look at the area. What happens to area over time? Area actually increases. So if area increases, what's going to happen to velocity? Velocity will decrease. So over time, velocity will decrease. Using that logic, B and D can't be the answer because it shows that velocity is increasing. Velocity must decrease. Will it be linear or non-linear? Basically, I can teach you another trick. It can't be C because it's showing us that electrons stop moving at end Y. That's wrong. So it's not this either. It has to be A. And remember, the variation is non-linear. Okay, so 32 is A. Moving on to 33. Important question. The power output of an electrical supply is 2.4 kilowatt at a potential difference of 240 volts. The two wires between the supply and a kettle have resistance of 0.5. There are two wires. That's the key point. What is the power supplied to the kettle and what is the PD across the kettle? Let's see. Come on. So let's find out the current. We know that P is equal to IV. 2400 is equal to 240 into I. I is equal to 10 amperes. Okay. So we have 10 amperes flowing through here. So V is equal to IR. V is equal to 10 into zero point 0.5. That's 5 volts. This is 5 volts. This is also 5 volts. So the total loss in the wires is actually 5 plus 5, 10 volts. So out of 240 volts, 10 is lost. So we only have 230 volts left for the kettle. Okay. So it can't be 235. It's 230. Now the power of the kettle. So we know that the current flowing through the kettle is 10 amperes and P is equal to I square R. So 10 square into 230. 10 square into 230 gives us a value of, sorry, it's I square R, right? We are going to use IV. My bad. Sorry, guys. P is equal to IV. So it's just 10 into 230, which is 2300 or 2.3 kilowatts. So that's why the answer is A. Okay. Now for 34. This is really important. The IV characteristics of three objects components are given. The straight line passing through the origin will be a metallic conductor at room temperature or constant temperature. Sorry, constant temperature. Y. That's Y. The semiconductor diode actually has infinite resistance in one end, and in the other end it has less resistance. Okay, so that's actually X. And for the filament lamp, that's actually Z. Why is that? It does not increase exponentially, rather it becomes like a horizontal line. Why is that? Because as the filament lamp gets hotter, as voltage increases, it actually becomes harder for electrons to flow and resistance increases. Okay, really important. Resistance increases over time. So the answer is B. Moving on to the last few sums. 35. A wire of resistance 9.55 has diameter 0.280. It is made of metal of resistivity this. What is the length of the wire? R is equal to rho L by A. So L is equal to RA by L. So R is 9.55. A is pi d square by 4. Pi into 0.280 into 10 to the power minus 3 whole square by 4. Divide by the resistivity 4.90 into 10 to the power minus 7. Okay. So that's how we did it. Wait. Here you go. What's the answer? 0.280 into 10 to the power minus 3 whole square by 4 into pi into 9.55 divided by 4.9 into 10 to the power minus 7. That gives us a value of 1.2 meters. So the answer is A. 36. A cell of constant electromotive force but with internal resistance is connected to a fixed resistor R using a potentiometer. A voltmeter measures the potential difference between the terminals of the cell. You know, the voltmeter across the terminals of the cell, it actually gives us terminal PD, okay? Not EMF, it gives us terminal potential difference. Which statement explains the change to the reading of the voltmeter as contact Z is moved towards end X of the potentiometer? Interesting question. Okay, come on. Let's try to understand this. So, the contact point, right? The contact Z is at this point at the moment. The cell has an internal resistor. How do you decrease loss volts? Actually, remember that EMF is equal to terminal PD plus the loss volts. So let's look at the logic actually. This is currently part parallel. This part is in parallel with this part series. Okay. So what happens if we, it's like this, it's kind of like this. Okay. Now what happens if we move it towards point X? If we move this to here actually, okay, if we move contact Z here, the whole series, like the whole circuit becomes series now. Beforehand it was like this. If I draw this section, if I zoom in over here, beforehand when it was at Z initially, it was like this. Some of it was in series and some of it was in parallel with resistor R basically. Okay, it was like this. Now when we move it to point X, do you know what happens to the circuit? It becomes like this. Resistance X is totally in series with the battery. Now hear me out. When two resistors are in series, you add up the resistance, right? So resistance actually increases compared to before, since this is in series with X. So when resistance increases, the current in the circuit will decrease, loss volts will decrease, and the terminal PD, or the reading across the terminals of the battery, will increase. That's why the answer is C. Interesting question. Always remember, in series, resistance is higher. 37. A cell of electromotive force E and negligible IR is connected to a circuit. The circuit has currents I1, I2, I3 and potential difference V1, V2, V3. Which equation represents Kirchhoff's first law? It has nothing to do with voltage, guys. That's the second law, okay? It has nothing to do with voltage. So we are going to get rid of voltage. So look at this. I1 is entering a junction. The sum of current entering a junction is equal to sum of the current leaving the junction. So I1 is equal to I2 plus I3. We are looking for that. So that matches with A. 37 is A. Two resistors are connected in series with a 6 volt power supply as shown. What is the resistance of the variable resistor to give a potential difference of 1 across the 12 kilo ohm resistor? So since the EMF is 6, if this gets 1, this will get 5, right? Okay, so we can do it like this. 12 according to potential divider, 12 divided by 12 plus R into EMF 6 is equal to 1. You could also do it this way, R divided by R plus 12 into 6 is equal to 5. Both work, okay? Let's solve this. So 12 into 6 is 72. 72 is equal to 12 plus R. R is equal to 60. 60 kilo ohms is the answer, 38C. Now 39. A nucleus of magnesium decays into a nucleus X by emitting a beta plus particle. The decay is represented by the equation shown. So for beta plus decay, do you guys know what happens? Your mass number remains the same at 23, but your proton number decreases by 1 because we need to conserve charge, okay? So it's actually 2311, okay? So 39 is C. 39 is C, 38 was also C, 37 was A, and 36 was C, right? Okay. Moving on to question for you last. In beta minus decay, a neutron inside a nucleus changes to a proton. Which statement describes the quark composition of the nucleus during the decay? In beta minus decay, what happens? Look at this. In beta minus decay, basically mass number remains same, this one increases by 1. So what happened really? Proton number increased. How? A neutron was converted to a proton, so up down down was converted to up up down. Basically one down quark was converted to one up quark, so down quark decreased by 1. Okay, the down quarks decreased by, wait, can you give me a bit? Sorry, it was 23 and this became 11. It decreased by 1. Yeah, so I was saying x 23 12, after beta minus decay it's going to y 23, it increases by 1. So one neutron was basically converted to one proton, or up down down converted to up up down. What happened? Up quark increases by 1, down quark decreases by 1. Let's look at that. The number of down quarks decreases by 1. Yes, that is true. So the answer is A. Alright, so if you have other questions you can ask me. I'm gonna link the playlist for paper 1 up here. Remember to subscribe to the channel, it will help me a lot. And I'm gonna link May June 21 variant 1 up here, and May June 2021 variant 1 3 down here when I'm done recording that. Okay, so see you guys later.